Hello, welcome to another video on differentiation. Today we're going to be continuing the topic of the last video, which was absolute and relative extrema, and we'll be touching more on relative extrema today. Let's get started with this problem here. So for what value of k will this function have a relative maximum? So don't get thrown off by variables, by like additional things other than x. K is just going to be a constant, so when we do things with it, we're just going to treat it like it was some number. If you want, you could like plug in a value of k and then just like back substitute. Like you could say, oh, k is 2, and then do this whole problem like that. But you just have to make sure to convert it back to k, later. So we're just going to keep in mind that k is a constant and just not plug in anything for k for now. So we're going to let this function be x over k, x plus k over x. We're going to rewrite this because they're asking for a relative maximum here. So we're going to want to differentiate this function. Find out a little bit more about what the derivative of this function is. And then we can figure out whether we want to make a sign chart or use a second derivative or something like that. So now we're going to take the second derivative. I'm sorry, the first derivative, my bad. Okay, so when you differentiate this with respect to x, right? So we're differentiating the first derivative with respect to x. What's going to happen is this x is going to go to 1, right? And then k will remain as a constant, so we'll multiply k multiplied by the derivative of that part. And then the minus 1 is going to come down, right? So minus 1 x to the minus 2, right? This is just power rule. Now I'm going to rewrite a little bit. So 1 minus k x to the minus 2. And then that is going to end up being 1 minus k over x squared. Okay, so something interesting here, right? We know that already if f prime exists, then it has to be 0 in order for a relative extrema to be true, in order for a relative extrema to exist, right? Now obviously in some cases f prime may not exist, like in this little example graph that I've drawn here. F prime does not exist at this point, but that point is a relative maximum. It also happens to be a absolute maximum. But this is just to show you that relative maximum does not force f prime to be 0. But if it does exist, right? If it is differentiable at that point, then it has to be 0. And this is the premise that we use when we find critical points, right? When we say critical points, we say that f prime of x, we say it's 0 or doesn't exist, right? And so these are the points where there could possibly be relative extrema. So okay, but at x equals minus 2, hopefully you can see that this is definitely going to exist, right? So if we go ahead and plug in x is minus 2 here, and at 1 minus k over minus 2 squared, it's going to be 1 minus k over 4. And you know that this is going to exist, right? For some, it doesn't matter what k it is, it's going to end up being a finite value. So this has to be 0, right? So if you set 1 minus k over 4 to 0, you get that k is 4. So immediately, if you were like running out of time, let's say, you could just pick D right away. Because, right, that is the only answer choice on here. Now we're just ignoring E for now. But out of these, that's the only one that could possibly get you a relative extrema, let alone a relative maximum. And in fact, that is the only value of k that can give you relative extrema at all. But, okay, perhaps this is not a relative maximum. So we still have to figure out whether it's a relative maximum or minimum, just to make sure that College Board doesn't trick us. Although, frankly, you could also just move on here if you're like running out of time or something like that. Okay, so let's look at the sign of the second derivative to see if it's a relative maximum or minimum, right? Because right now we don't know that. We know that there might be an extrema at k equals 4. Right, but we don't know whether it's a relative maximum, which is what the question is asking. So we're going to take the derivative of our first derivative expression, which is right there. So 1 minus kx to the minus 2. And then minus the 1 is going to go away because the derivative of a constant is 0. But the minus sign does not go away. Something to keep in mind. And then minus 2 will drop as a power rule. So, right, this is just applying the power rule here. Oh, and we did forget a k. There's a k as a constant right there. So minus 2k x to the minus 3. Right, because remember this k is still living there, so we've got to account for it. Of course, you could have plugged in k equals 4 and figure out the derivatives like this, but it's really just a matter of preference. So I get 2k x to the minus 3, and then you can just write this out a little bit here. And now we're going to plug in these values of k equals 4 and x is minus 2 and see what the sign of the second derivative is. So f double prime of x is minus 2 is going to be 2 times k, which is 4, right, over minus 2 cubed. So whenever you're cubing a negative number, it's going to be negative. So just pop a negative sign right there, and then you'll get an 8. So minus 8 over 8 is just going to be minus 1. That's less than 0. Okay, now that's a good sign, because if the second derivative is less than 0, what does that mean? Well, it means it's concave down right there. And if you just draw a quick little graph of what concave down might look like, right, it should be a little bit more clear to you that that's going to be a relative maximum, right? Assuming that the derivative is 0 right there, and we know that, right? That's what we just checked before. We know that the first derivative is 0, and we know that it's concave down at that point, so we know there's going to be a relative maximum there. So the answer to this question will end up being D. And remember, you could have just picked D just by picking the point that could have been a relative extremum, but yeah. Okay, so here's our next problem. We've got the graph of f prime. That's important to note. And we're describing all the relative extrema of f. So what we're going to do here, so where is relative extrema when we're talking about like f prime here? So when f prime changes from positive to negative, that's going to be a relative maximum, right? And then if f prime changes from negative to positive, it's going to be a relative minimum. Now, most common way to do this probably is a sign chart, right? But we have the graph right here. We don't need no sign chart anymore. We can figure out the sign from the graph. So these answer choices, just looking at a skim, they're looking at, we want number of relative maximum and number of relative minima. So let's figure out what the number of relative maxima or minimums are. So where does f prime go from positive to negative? So that's sort of like approaching from the top, right? And I see 1 point right there. So positive over here and then negative over there. Nowhere else does this happen. So this means that we know that there's one relative maximum, and we can eliminate anything else that doesn't have one relative maximum. So bye-bye, bye-bye, and bye-bye. So this is a good sign that we have 2 here, because think about it from the College Board's perspective. They don't want you to shortcut or short circuit this question just by figuring out what the number of relative maximum were and then just like eliminating everything else. So it's good that there's 2. This is a somewhat common pattern with College Board problems. Again, not super essential to solve the problem, but it's good to know because it increases the certainty of the step that you're doing, which is always nice when you're in a pressurized, timed environment in a test. So back to the question here. Now we're going to figure out how many relative minima there are, and to do that, we have to figure out where f prime changes from negative to positive. So that happens in 2 places. I see one right there, and I see one right there. Right? So that's 2. And there we have our final answer, A. this question. Now note that you can also draw a sign chart if you really want to use a sign chart. I mean, go ahead, right? So f prime, except you kind of have to name these points, which gets a little annoying, but you can do that, right? Like it'd be positive over here and the negative over here, and then you just have to figure out the same stuff that we did here. But when you're timed on these questions, it's always best to go for the most direct answer, and the most direct answer comes from the graph. So yeah, that'll be it for this video. I hope this was helpful, and I'll see you guys in the next one.